Hello everyone, today our team will present about full system of renewable energy sources. I will introduce renewable energy sources. Renewable energy is energy obtained from natural resources that are continuously replenished, such as sunlight and wind. Common renewable energy technologies include solar panels and wind turbines, which convert natural energy into electricity for homes, industry, and communities. Next, significance of renewable energy sources. Renewable energy is important because it helps reduce greenhouse gas emissions and environmental pollution. It also provides a sustainable and reliable energy supply while reducing dependence on fossil fuels. In addition, the renewable energy sector creates job opportunities and supports economic growth. As the demand for energy continues to increase, renewable energy plays a vital role in building a cleaner, greener, and more sustainable future.
Now, we move on to the first case study, which is hybrid solar wind renewable energy system in Malaysia. As we know, a hybrid solar wind system in Malaysia combines solar panels, small wind turbines, and batteries to make electricity. This is because Malaysia has low wind speed. These systems are not connected to the main national grid, instead they are used an independent microgrid for remote place. Next, how it works. First, where it is used, for example like pulau perhentian, remote village and offshore oil platform. Now we move on to the first case study, which is hybrid solar wind renewable energy system in Malaysia. As we know, a hybrid solar wind system in Malaysia combines solar panels, small wind turbines and batteries to make electricity. This is because Malaysia has low wind speed. These systems are not connected to the main national grid, instead they are used independent microgrids for remote place. And then how it works. First, where it is used, like pulau perhentian, remote village and offshore oil platform. Second, where the team works, like solar panel generate power on sunny days. During the rainy monsoon season, when the sun is hidden, stronger coastal winds take over to the turn turbines. Last, for the battery powers, the batteries store extra energy during the day and release it at night, keeping the electricity running non-stop. For the scientific instrumentation used, first solar irradiance sensor, second anemometers and wind direction sensor, third battery management system, last smart meter and IoT-based monitoring system. Next, for the benefits, it's more stable power generation than using a single renewable sources. Second, it's suitable for remote and rural communities. Third, it reduces greenhouse gas emission. For the challenge, first, it has high initial investment. Second is complex system integration. And it maintenance of multiple energy sources and storage systems.
So now I will explain on the case study 2, which is wind power Hornsea in the United Kingdom. Hornsea is a massive multi-phase green energy cluster located up to 120 kilometers out in the UK's North Sea. The Hornsea 1 and 2 are fully operational. Meanwhile, the Hornsea 3 is currently under construction in 2026. The benefit of this wind power is that it has a massive generation scale with an outmatched power output. Secondly, the electricity generated is high. A single rotation can generate enough electricity to power an average household for 24 hours a day. Lastly is the net zero acceleration. The wind power supplies clean, emission-free electricity and displaces millions tons of carbon dioxide annually. So how does the Hornsea wind turbine works? By using the electromagnetism principle, electrical energy is generated by rotating the magnet inside a coil of conductive wire in a wind turbine. That rotation is achieved by the power of the wind. Firstly, the wind turns the blades of the turbine, which are connected to a rotor. Secondly, the rotor will spin a shaft inside the nacelle. The movement of a shaft inside the generator will create electricity. The electricity generated will be transmitted through the cables within the turbine structure, down to the seabed, and then to the shore through underwater cables.
For case study 3, I chose Badla Solar Park. Badla Solar Park, located in Rajasthan, India, is one of the largest solar plant in the world. It holds the capacity of approximately 2,245 megawatts. The solar park uses thousands of solar photovoltaic panels or PV panels to convert sunlight directly into electricity. This helps reduce the use of fossil fuels and supports the development of clean and sustainable energy. To ensure efficient operation, the solar park uses several scientific instruments. Firstly, a pyranometer. It is to measure the amount of solar radiation received from the sun. This helps to determine the available solar energy. Second, a solar irradiance sensor monitor. It monitors the intensity of sunlight reaching the solar panel, allowing the operators to evaluate panel performance. Thirdly, a temperature sensor. It is used to measure the temperature of solar panels and the surrounding environment. High temperatures can reduce the efficiency of solar panels. Next, an inverter. An inverter converts the direct current or DC current produced by the solar panel into alternating current or AC electricity, which can be supplied to homes and industries. Next, a weather monitoring station. The station records weather conditions such as temperature, wind speed, humidity, and rainfall. This information helps predict energy production and maintain the system. Finally, a data logger and monitoring system. This system collects and stores data from all the instruments, allowing the operators to monitor the performance and detect any problems quickly. The benefits and challenges. Firstly, the creation of jobs. The development and operation and maintenance of the solar park have created thousands of employment opportunities, especially for the local community. This helps improve the regional economy and supports local livelihood. Secondly, it improves the accessibility of energy. The electricity generated by Badla Solar Park is supplied to multiple states in India, providing reliable energy for homes, businesses, and industries. Thirdly, environmental benefits. Since solar energy is a renewable source, it reduces dependence on fossil fuels, lowers greenhouse gas emissions, improves air quality, and helps combat climate change. However, there are also several challenges. One challenge is that the dust accumulation on solar panels can reduce their efficiency, so regular cleaning and maintenance are required. Another challenge is that solar power depends on weather conditions and sunlight availability. Electricity generation decreases during cloudy weather and stops at midnight. At night. In addition, large land areas are needed to install thousands of solar panels, which can limit suitable locations for solar farm. Finally, energy storage systems are necessary to ensure a stable power supply during periods with little or no sunlight, but these systems can be costly.
To wrap up our presentation, let's look at the main takeaway from a full system of renewable energy source. First, adaptability is everything. Our case study showed that there is no single solution for every location. For example, remote areas or isolated islands in Malaysia benefit most from independent hybrid microgrids. On the other hand, countries like UK and India show us how massive, large-scale wind and solar farms can power entire regions when the geography allows for it. Second, we have to acknowledge that there are real hurdles to overcome. Setting up this system requires a high initial investment, complex engineering, and dealing with harsh environment, whether that's a brutal marine environment at sea or intense heat in the desert. But with the right scientific monitoring tool, these challenges are completely manageable. Ultimately, this is our path forward. Transitioning to full renewable system is no longer just an option. It is a necessity to drastically reduce global emissions, protect our ecosystem and secure, sustainable, long-term energy for the future.